Welcome to Mr. Chalk's Revision Tips. In this video, we will look at concentration, solvents and solutes, and working out concentrations using moles. So, when we're thinking about concentrations, we need to be able to think about whether something is a high concentration or a low concentration. So a high concentration of a substance in a solution means that there are a lot of it relative to the solution's volume, right? So for example, salty water. A low concentration of a substance in solution means that there are few of it relative to its volume. So for instance, if you put a little bit of food coloring into water. So three keywords that we need to be aware of are a solvent, a solute, and a solution. So if a substance is soluble, it will dissolve in a given amount of liquid, right? And this is called the solvent. A solute is a substance that dissolves to make a solution. So for instance, in salt solution, the salt is a solute, and a solution is when either a solid or a gas dissolves in a liquid and forms a solution where the substance is dissolved in it and can move around. The concentration of a solution is measured in grams per cubic decimeter, right? So the greater the concentration, the more dissolved particles there will be in the solution. So equal volumes of different solutions that have the same concentration contain the same number of particles. Right, it's worth noting that 1 centimeter cubed is the same as 0.001 decimeter cubed. So to turn centimeter cubes into decimeter cubes, you just need to divide it by 1,000. And the equation for concentration is just the mass of the solute in grams divided by the volume in decimeter cubed. So if we had 15 grams of a solute that is dissolved in 3 decimeter cubed of water, we would calculate the concentration to be 15 divided by 3, which would just give us 15 grams per decimeter cubed. The concentration is the number of moles of a substance dissolved in 1 decimeter cubed. So the same as we've just looked at, we can go and substitute the mass in grams for the number of moles, and the calculation for doing this will just be the number of moles of a substance divided by the volume of the solute in decimeter cubed. So if we had 12 grams of sodium hydroxide dissolved in 5 decimeter cubed of water, calculate the concentration. So the first thing that we'll work out is how much does 1 mole of sodium chloride weigh. So 1 mole of sodium chloride, we'd work that out to be 48.5 grams. Then we'd look at how many moles of that we have, and we'd work that out by 12 grams. So 12 grams we've got divided by the mass of the 1 mole, which would give us 0.247 moles. We'd look at work out the volume of the solution. In this case, we've already got it in decimeter cubed, so we don't need to worry about that. And finally, we'll calculate the concentration. So that would be 0.247 divided by 5, which would give us a concentration of 0.0494 moles per decimeter cubed. If we had 12 grams of sodium hydroxide dissolved in 20 centimeter cubed of water, same as before, work out the mass of 1 mole of sodium chloride, see how many moles of sodium chloride we have, but this time you have to go and convert the 20 centimeter cubed into decimeter cubed, so you just do that by dividing it by 1,000, and then you could go and calculate the concentration after. Thanks for watching.